All right, guys, are there any questions over the homework assignment so far? Any questions over any of the homework assignments?
Yeah, Brennan. No.
Guys, answer yourself. Yep. Any other question or any questions on the homework that y'all want to look at?
Yes, sir.
What we're looking at today is applying transformations to the functions themselves. End up getting enough sheet? So the first functions we're going to look at, or first transformations that we're looking at, are vertical and horizontal translations. So this is already on your note sheet because it's located right here and here. Guys. So when we apply a horizontal or vertical translation, we're going to be referring back to these two forms here because these will help us be able to apply the transformation either left or right for our horizontal or up or down for our vertical. And we will use these general forms to be able to apply the function itself. So when we're talking about horizontal translation, we're affecting the input, either moving the inputs to the left or right a certain amount, or vertical translations, we're affecting the output, we're moving it up or down. Now this will make a little more sense when we start actually applying the translations. Now the first one we're looking at is we want to write a function g whose graph is a translation 3 units down of the graph of f. So what we're saying is we want a new function g of x. So we're looking at a function g of x as the one we want to apply or get once we finish applying this translation of 3 units down. Since we're moving up or down, we're talking about a vertical translation. So in the general form, we're talking about f of x plus k, where k is that translation either up or down. Now, how far are we moving it up or down? 3. So k is going to have a value of 3, but would it be positive or negative? So we're moving up because we're moving down. So it's going to be minus 3 since we're moving it down. So the value of k for this here is minus 3 because it's moving the whole function down 3. Now f of x is just our function. We haven't done anything to it, so it's still just f of x, which is going to be 2x plus 1. So we can replace it with 2x plus 1 because we still just have f of x. Any questions on this so far?
A whole lot.
Is there anything in front of those parentheses? No, so we can drop them. We don't need them. We put them in there just in case that we needed to apply something to it. If there was a number out there or a sign we had to input. Yep. Are there any like terms? The 1 minus 3? So we can combine those? No. This is just replace, g of x is just another way to write y. It's defining the function.
That's the answer?
Yeah.
How'd you get that? By doing those steps you just did on the board. Looks like we got the same thing. I'm confused. So, oh, you add 3 to 1, negative 1, which makes 2.
Yep.
I think
So we added negative 3 to 1 to give us negative 2. Because what we're doing is we're moving all the points on this graph down 3, and it gives us this new function here. Questions on this here? Seeing a few more might help kind of see how this works. Okay.
I cheated my way through most of it.
I think we all did.
Okay, I'm just rewriting the function down because, again, it's not visible on the screen, but you all still have it on your note sheet right above it. So for this next one here, we want to write a function h of x, whose graph is a translation 2 units to the left of f. So when we talk about a translation left and right, we're looking at the general form f of x minus h, where h is that translation to the left or right. So this here is just the general form for moving it left or right, f of x minus h, where h is the value, is representing the value of that movement. Now for this here, where are we moving? Left, how far? So would the 2 be positive or negative? Negative, because when we go to the left, it is negative. Yes. Because minus a negative is going negative and negative is going to make it. So now, if you're able to remember that because we are moving left, it is negative, and that negative does make a positive, you could write here, we could rewrite here, that is a plus. I'm going to leave it as minus negative, then rewrite it as plus, because it might be helpful, because if you are doing the homework and want to look back at this, it makes sense that it didn't just change to plus, we didn't plug it in as plus. It actually, that negative and negative made it plus. Because again, as we talked about this yesterday, the horizontal left and right is kind of the opposite of what we think. Because here, x plus 2, it's moving to the left 2. But when we plug it in, we'll plug it in exactly as it is. Left is negative 2. So h is the movement left or right. So where are we moving? How far? And left is considered negative. And a negative and negative make a? So far. Because, again, we need it as an actual function like this here. Because we're using this to get us to understand how it's going to change, how it's changing this here, the 2x plus 1, with this movement. Now looking at this here, do I have f of x anymore? No, we have f of x plus 2. So what did I do? I replaced this x with what? X plus 2. So that means this x here has to be replaced with what? Now what would that give us? Because we'd still have the 2. We don't have x anymore. We have what? The x plus 2. Yes. We still need to get rid of the parentheses and make it look a little nicer.
Oh,
But
like terms, that'd be 3. So it'd be H.
goes distributive.
2x
Plus.
plus 1. Add 4 plus 1, 5.
Yep. And that would be it.
H x equals 2x plus 5.
Yes.
I don't know how I got that.
Any questions on this here? So we used the general form, the f of x minus h, to be able to apply this movement of left 2, which gave us the f of x plus 2. We plug the x plus 2 in for x, because that's what we have now is f of x plus 2, and then simplify down. We'll look at a few more. Any other questions on this here? Let's look at this one here. Write a function g whose graph is a translation 5 units up of the graph of f. So we move a function up or down. We're using the general form of f of x plus k.
And k is 5.
Yes.
So, yes.
Would it be positive or negative?
Positive. Down's negative. Down and left's negative. Up,
Yes.
right, positive.
Guys. So the value of k is going to be positive 5, so we have plus 5. Now we still have f of x. We haven't, it's still just f of x. And our function this time is 4x minus 9. So we're going to replace this f of x with
X minus
4x minus 9. Is there anything in front of the parentheses that we have to multiply through? No. So we can drop the parentheses, telling us that g of x is equal to 4x minus 9 plus 5. Combine like terms.
So,
That's it. Questions on this here? So this right here is the graph of 4x minus 9. Now what we did, the movement we did is we moved the entire graph up 5 units, yes? And the equation that we got is 4x minus 4. 5. So if we look at this point here, is it right here? We're at the point 3, 3. If I can get there. Yeah, it won't let, there we go. So if it moves up 5, it's going to be at 3. 3, 8, because it moved it from 3, 3 to 3, 8. So it's moving them all up 5. That's all that we did. So this is just the graphical version of what we just did. Yep. We don't have to graph it, but sometime, no. No. I show the graphical version of it here and there just so that y'all can see the movement, see what it actually did. Because a lot of times just seeing the numbers doesn't mean a whole lot, but seeing kind of the physical movement makes a little more sense. Now for this one here, we're wanting to translate the graph 1 unit to the right. Since we're moving left or right.
So it's going to have to be G, parentheses, X, H.
So here it asks for H. So G of X, I would be fine with that because it's just a way to name it. Now,
F would be 4x minus 9.
so we're still using that, yes. So I'll write it over here so that we have it. Now the value of H is our movement to the left or right. It would be 1. Yes.
This is left, right,
It would be positive 1. So in place of X, we replace it with positive 1. And since it is positive, we don't have to put a plus sign. It's understood when we don't have that, it is plus, not negative. So we have this. First step to it. Because this is helping us understand how it's going to affect this function here. So we still have to apply it to the function itself. So this time, we don't just have f of x, we have f of x minus 1. So anywhere there's an x in this equation, we're replacing it with x minus 1. So this x is now going to be x minus 1. So instead of having 4 times x, we're going to have 4 times so we have the 4 in front of the parentheses, yes? So we have to
5.
distribute. 4 times x is
4x.
4 times negative 1 minus
9. 4 minus 9. I know negative and negative makes positive. So.
when we subtract a negative, it's a bigger negative. Yes. Questions on this here?
Now, as long as you can do this on wherever we're doing the test.
Any other questions on this here? We good with this one here? We're going to look at 2 more. So here, we're saying that f of x is 3x, and we want to translate it 5 units. Now, it didn't give us a function to start with, so we can just call it g of x. With vertical translations, when we're moving up and down, we're talking about f of x plus k. Because this is the way we describe a vertical translation. It's a cursive lower k. Now, k in our case, or in this problem here, is going to be what? Would it be positive or negative? Positive because we're going up. Have we done anything with f of x, or done anything to change it? No, it's just still f of x, so our function is So we can plug it in. Is there anything in front of the parentheses? So we can just drop them? So g of x is 3x plus.
Yeah, if you had ones like that. Next one the same way?
Almost,
Oh, it's not.
except we're moving left or right. We're actually moving right. Right? Right. Are we ready for the next one? Okay. So for this one here, we're wanting to move the function to the right, which is going to be what we can call g of x again. So we're looking at f of x minus h. So the value of h is going to be what? Positive 4. So we write in just 4. Because if it had been negative 4, we would have put in negative 4. So here, we don't have f of x anymore. Because if we had f of x, we would just replace it with the absolute value of x minus 3. But this time we have f of, so everywhere there's an x in this function, so right here, it's going to be replaced with x minus 4. Let's do it, say it this way. If I said f of 6, what are we going to do? We're going to replace every x with 6. You remember evaluating functions where we would plug the number in and then simplify down, yes? We're doing the same thing here, except instead of just having a number, we have an expression. We have these two terms. We're doing the same thing. So here we're replacing every x with the x minus 4. So we'd have the absolute value of x minus 4, because that's the only thing inside the absolute values was just the x. Then we have
Like terms?
yes, if there are any like terms to combine, we will combine them. Do we need those parentheses? No, so we can drop the parentheses, which would give us the absolute value of x minus 4. And that's it. And the reason that's it is because, again, those absolute values prevent us from moving that minus 3 in.
Because it would turn the minus 3 into just negative 3.
Because whatever comes out of the absolute values has to be positive.
Yeah, because anything inside of those positive.
Yes. So that's as far as we can go. We can't bring that negative 3 in. Questions on this here?
Oh, great. Negative x.
So we're doing an exactly similar process. We've got two new setups. For when it's a reflection across the x-axis, we are using the form of y equals negative f of x. When it's a reflection across the y-axis, we're going to be using y equals f of negative x. So again, we're using these general forms so it helps us understand what's going on, how the translation is affecting the function that we're working with.
The reason we do that is because the number is in an area that's negative.
So with negative f of x, what we're doing is affecting the output, whatever number would come out. If the number that comes out of the function was 4, we're changing it, making it 4, because it's going below the x-axis. And for y, the number that we would plug into the function, if it was positive, it is now going to be negative. And if it was negative, it's now positive, because we're moving it from here to here, or vice versa. And here, we're moving it here to there, and here to there, respectively. We're flipping it across that axis. Now, the first one here, we want to write a function g of x, whose graph is a reflection in the x-axis. So for our general form of the x-axis, we're looking at negative f of x. So that's the general form of this reflection. So what is our function? The absolute value of x plus 3 plus 1. So we can replace f of x with that.
Oh, this time you can bring that 1 to that 3. Oh, well that. Positive, so you can bring it in there. Oh, so you're.
But we'd still want to leave it outside, just because of, if we did move it, it kind of changes what's inside. We can't just add into an absolute value. Questions on this so far? There's that negative. So we'll have to multiply. Essentially, it's negative 1s out front. So we need to multiply everything in there with that negative 1. We don't multiply into the absolute value. We just multiply the absolute value by negative 1, which is just going to tell us that it's
Same exact thing.
with just a negative out front. And negative 1 times 1.
It's the same thing. Oh, dang. That goes
Yep. Okay, we ready for the next step? Yes? That's it. That is it. Any other questions on this here? Questions on this so far? We ready for a reflection in the y? Because this one here, we want a function h of x, whose graph is a reflection in the y-axis of the graph f. So our general form is f of negative x. So this is just the general form for reflection in the y-axis. Any questions on this so far? So this time, when we take this here and apply it to our function, we're replacing every x with negative x. So this x here is now going to become, so the absolute value of negative x, 3, so we replaced the x with negative x. Kind of like what we did with the left-right translation, except instead of having more than one term, we just have negative x. Is there anything in front of these parentheses? No, I mean, there's the absolute value bar, but...
So drop them, which makes the extra positive. We can't be negative inside the...
We can have a negative number inside the absolute value, but when we evaluate it, it's going to come out positive, because anything that comes out of an absolute value is positive. Yeah?
It just seems like an unsolved problem.
Because we're just looking at the function. We're not actually evaluating or solving it.
I didn't catch that at the beginning.
Any other questions on this here? We're going to look at two more, and then we are going to be done for today. So we're going to look at this one and the next one. So for this one here, we want to write a function h whose graph is a reflection in the x-axis. So if we're talking about a reflection in the x-axis, we're talking about negative f of x. Negative f of x. Now, our function here, f of x, is absolute value of x minus 5. Minus 4. So we just plug the function in because we didn't do anything with the f of x. We just apply the negative to it. So we end up getting negative parentheses, x minus 5 minus 4 close parentheses. Distribute the negative. Negative absolute value of x minus 5.
Minus 3.
Negative times a negative is a
Positive, so 5.
So we're multiplying the absolute value by the negative, so it's just negative absolute value of x minus 5. Then the negative times negative 4, the negative and negative make a plus, and we have 4. Questions on this here? Last one we're looking at today. We want to write a function g, whose graph is a reflection in the y-axis of the graph of f. So we're looking at g of x is equal to. So we talk about a reflection in the y-axis. So f of
Negative x.
So we're going to replace every x in the function f of x with negative x.
So it's going to be g of x equals net, no, just negative.
Absolute value of
Absolute value of negative x plus 5 minus 5 line.
Answer.
Since we haven't finished the notes, we still have vertical stretch and vertical shrink left.